So basically, a reduced row echelon form is nice because it actually gives us the answer to the system of equations right away. So let's look at this example. I have here the reduced row echelon form for the augmented matrix for a linear system. So we can just actually eyeball these and tell what is the answer. But let me actually kind of do this the long way. Here, if you were to write the equation for this guy, it's actually going to be 1x1 plus 0x2 equal negative 2, and then 0x1 plus 1x2 equal to 3. So, well, the answer is pretty simple. I'm going to have x1 equal to negative 2 and x2 equal to 3. So the answer to this guy is going to be just negative 2 and 3. So it's just actually just the right hand side that we have here. The same thing is going to happen here. I don't see anything fancy here, so the answer to this system of equation is just going to be negative 2 and 3 and 2. And that's pretty much it. Now then, I have this 4 here. So, this whenever you have a column that has a number that is not a leading one, this guy is going to be the free variable. So my x3 here is going to be the free variable. If I were to write the equation form for this guy, that's going to be x1 equal to negative 2, and then x2 plus 4x3 equal to 3. So the answer for the system of equation is going to be that my x1 is going to be negative 2, my x3 is 3, so it can be anything, and then my x2 is going to be just 3 minus 4x3. Okay. Notice how we have a row a row of entirely 0 here. And that's okay. It doesn't really do anything, because if I were to write the equation for this guy, it's actually going to be just 0x1 plus 0x2 plus 0x3 equal to 0. And there's no harm in that. So it doesn't really do anything. Let's now look at the other example. I'm gonna have, let me actually write the equation for this guy. I'm gonna have, it's actually quite the same as this guy. I'm gonna have x1 equal to negative 2x2 plus 4x3 equal to 3. And then I'm gonna have 0x1 plus 0x2 plus 0x3 equal to 1. Oh, there's trouble here. This guy, I cannot have 0x1 plus 0x2 plus 0x3 equal to 1. So this guy actually has no solution. So basically, whenever we have something that looks like this, we're gonna have a problem. Whenever we have a row that the leading one actually appears in the last column. Whenever we have something like this, that's going to be when my 0x1 plus 0x2 plus 0x3, or maybe you have more variable, but you have the entire equations, entire left-hand side, it's going to be 0, but your right-hand side, it's going to be a 1. So you have something that looks like 0 equal to 1. So whenever something like this happens, whenever your leading one goes in the last column, this is actually going to be the only case when your system has no solution. Okay, so let me now move on. This guy, so my free variables are going to be my x3, so it's going to be this guy. And my x4 is going to equal to 2. So I'm just going to write this down. My x3 is going to be free variable. My x1 is going to be negative 2 plus x3. Negative 2 plus x3. And then my x2. And then my x2. Oh, wait a minute. My x2 is going to be 3 minus 4x3. Okay. So that's the answer for this system of equations. And the last one. I'm going to have, well, this one is once again pretty simple. My x3 is going to be a free variable, so it's going to be just x3. My x4 is going to be 0. And then my x1 is going to be my notice that my right hand side is actually entirely 0. So my x1 is going to be just x3, and my x2 is going to be negative 4x3. Now then, let me point out one thing real quick. Whenever the right hand side is just 0, this kind of equation, it actually is pretty special. It actually has a name. This is called a homogeneous. This is called a homogeneous system of linear equations, and it's actually going to be pretty important later on. But in any case, here's how the reduced row echelon form for the augmented matrix actually tell you the answer to the system of linear equations.